Okay, so more functional groups, double bonded functional groups still, two final types of functional group, and these are the esters and amides. These molecules both come about due to a reaction with a carboxylic acid and either an alcohol, as is the case with an ester, or an amine, as is the case with an amide. So the formation of these two molecules is due to carboxylic acid, so that C double bond of both of those molecules originated as a carboxylic acid, reacting with, in this case over here, an alcohol. That gives us an ester, carboxylic acid with an alcohol, or in this case, an amine, and this would have actually been ammonia. We'll just give it the general name amine. And so that gives us an amide. So both these molecules start as carboxylic acid reacting with another molecule, either an alcohol or an amine. Esters then are derived from a carboxylic acid and alcohol. So the functional group lies usually within a larger molecule. There it is in the middle of this molecule. And to name it, we have to first identify the component of the molecule that comes with the carboxylic acid. And it's right there. That's the carbonyl group. Alcohols do not have the carbonyl group. So this, with any associated attached carbons, is the component that came with the carboxylic acid, and the rest of it came with the alcohol. So we look at our carboxyl group, which was a 3-carbon, so that must have been propanoic acid. So we again go with propane. We take off the E and add O8. An O8 ending tells us it's an ester. The part that came with the alcohol is just a branch. That's a 2-carbon branch. Ethyl propanoate. Second example, there's my C double bond O. That's the carboxylic acid that started it all. Here's the oxygen. So there's my ester group. This must have been an alcohol. So in terms of the names, that's going to be a methanoate because it's a 1-carbon carboxylic acid with a butanol, so butyl methanoate. Amides come from an amine and a carboxylic acid. It could be ammonia, which would yield a primary alcohol or primary amide. I'm just going to deal with a couple of larger ones. To name, it's much the same. We identify the carbonyl group because that's the carboxylic acid, and the rest of it, including any carbons attached to the nitrogen, must have come from an amine. So that's the amine component to this molecule. There's my carbonyl group, so this is my carboxyl component. And to name, same as we did the esters. That would have been butanoic acid, so that becomes butanamide. And the part attached to the nitrogen, this methyl group, becomes an N-alkyl branch, so that's an N-methyl branch. So this name is going to be N-methyl butanamide. Here's our C double bond O carbonyl group. So this part came with the carboxylic acid. That's a 2-carbon carboxylic acid, so that's going to be ethanamide. And we have 2 N branches. So here's an N-ethyl branch, here's an N-methyl branch. And so as you already know, we would list those alphabetically: N-ethyl, N-methyl, ethanamide. Finally, a little bit more exposure, just 2 more examples. Here's my ester functional group. The carboxylic acid was a 1-carbon carboxylic acid. The alcohol was a 1-carbon alcohol, so that's just methyl methanoate. On the other side, we have our C double bond O, again, single carbon, that's methanoic acid. Bond N, there's my amide group. That's an N branch, and it's 1, 2, 3 carbons long, so that's going to be called N-propyl methanamide. That's a propyl branch on the nitrogen and N-propyl on a methanoic acid stem, so N-propyl methanamide. And that's it for esters and amides.